right here, multiplying slash dividing rational expressions. And it deals with the stuff that we were doing today, so that's probably where things are going to go haywire on us. But let's start with something easy. If you see this, children, example el número el uno. If you see 5y squared over 3, and you're multiplying, this is a multiplying one, 9x times 10y. This is all about cross-canceling. You don't want to multiply until you have cross-canceled everything that you can. And this is an easy one, but we get to some more that get a little goofy here. Okay? If you look at these two things, what is the same? Well, I suppose the first thing you should look at this. You should think about this as you need to prime factor all things. Or prime factorize. You don't have to do this, but this is how you should think about this. 5y squared is 5 times y times y, correct? 9x is 3 times 3 times x. 3 is already prime factorized, and 10 is 2 times 5 times y. And some of you will be able to do this without doing that, but now you just look at what crosses off, what's the same on top is the same on bottom. Well, you've got this 3, which will cross off with one of those two 3's. You've got this y, it'll cross off with one of the two y's up there. You have this 5, it'll cross off with that 5 up there. Are there any other things like on top and bottom? Somebody say no. 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 And then you just remultiply. 3x times y is 3xy, and you have a 2 left on the bottom, and that is your answer. Really, we've kind of done this before, except we haven't quite done some of the stuff we're going to do. Everybody good with that? Because I'm sliding into something a little. Let's do one more, and then something that's maybe going to just make you smile. 4x squared y over 2z squared times 6x z to the 4th over 20y to the 4th. Now, you don't really need to do what I did in that last one and break it all down if you can see this, okay? This z squared and that z to the 4th will cross off, leaving you with what? Right, because this has 2 z's, that has 4's. This crosses off, you're left with a z squared on top. I don't have to put double z and then 4 up there. This y to the 4th will cross off with one of the y's up there and leave me with what? Where, Christine? I got 4 y's down there and 1 y up there. One of these is going to cross off with 4 of those, leaving me with 3 of them on the bottom. What about the numbers? 4 is going to cross off up here and maybe go into the 20 and leave me with a 5. 2 can cross off with the 2, leave you with the 1, go into the 6. How many times? 3 times. Anything else you see that crosses out?
Oh wait, no.
No, the x's don't cross off, they get multiplied. So what am I left with on top? 3. X squared times x is x cubed. Z squared on top over 5y cubed on the bottom. Congratulations. You've done the easiest humanly possible problems that you'll see. All right, ready? Take a deep breath. All right, write this one down. Y squared minus 16 over 2y plus 6 times y plus 3 over y minus 4. Okay, take a deep breath for me. Ready, Alex? You got that written down?
Yeah.
Okay, here's what you must understand, children. It's only factors that cross cancel. Because there's addition and subtraction signs, you have to be very careful. In other words, this, I cannot take this 6 into that 16. Things don't work that way. Because these are not factors, that won't cross off. The only way that I can get this to cross off with anything would be is if I get a y plus 3 as a factor somewhere on the bottom. I can't cross off these two y's because they're not part of the same expression. When you cross cancel, it has to be multiplication. Now I can change this to make it a multiplication problem by putting a y plus 3 times 1, and now it is a factor. But the only way this will cross off with anything is if I get a y plus 3 somewhere else. So remember the last time I said you need to prime factorize? Well, that's what you're going to have to do here. You need to look at your things and see what you can factor. And you'll actually have to write this out. For example, y squared minus 16 can be broken down into what? It's a perfect square one we just talked about. This is a perfect square, that's a perfect square. This will break down into what binomial? Y minus 4 times y plus 4. Y minus 4 times y plus 4. Okay, which is good because, see this y minus 4? Because this is one expression and I can make it a multiplication thing, I can now cross off this y minus 4 with this whole y minus 4. What can I factor this into? What can I take out of both these terms? 2. This isn't going to break into two binomials, but it'll break into this. 2 times y plus 3. And then you gasp in amazement that somehow, by your good fortune, there's a y plus 3 here and a y plus 3 there. So this crosses off with this. Continuing on. Does this 2 cross off with anything? Can I take that 2 into that 4? I cannot because it's not multiplication. That's what my answer is left with. I probably should have crossed these off when I factored them down so it doesn't confuse you. Your answer to this is y plus 4 over 2. That's what it simplifies down to. Don't worry, if you're confused, it'll get worse.
Yay.
Try this one on for proverbial size. Y squared plus 10y plus 25 all over y squared minus 9 times y squared plus 3y over y plus 5. As they stand right now, nothing will cross off. You have to factor. So let's do that. What does y squared plus 10y plus 25 factor into? It's a trinomial. It'll break down into two binomials, which would be, Eli,
1 plus 5
times,
1 plus 5.
correct, and more correct. Reverse FOIL. 2y plus 5 will give you this. Let's cross that off so I don't look at it anymore. How about y squared minus 9? Does it factor, Christian? Y squared minus 9. Can I break that into? To what? No. It's going to give me two binomials. Perfect square, perfect square. What gives me minus 9?
Minus 3 plus
Thank you very much. Minus 3 plus 3. Factor in, this breaks down to, what can I take out of both of them? A y, which is y plus 3 left over. This one doesn't break down, but you gotta remember it needs the break. It'll only cross cancel with the y plus 5. Now once you've got it all broken down, you look for common factors, and I have what? A y plus 5 and a y plus 5 a y plus 3 and a y plus 3. And I think that's it. I really probably should look. Sometimes they have you remultiply that out, sometimes they leave it in factored form. I'm gonna look to see, because nothing else breaks down when you left with them. What has that one? Y times y plus 5. What number was this? Somebody, what number is this? Yeah,
Question 16.
it's 15, I think. The answer, as they give it, you could multiply the y times y plus 5, or you can just leave it as y times y plus 5 all over y minus 3. And again, why don't these cross off? Because these are not factors. You have to look at this as one big grouping. The way that crosses off is with something like that. You want the really hard one, Jake? Say yes. Come on. Live dangerously. What's that? Oh, nobody will ever get that one. Here we go. See how far you can get on this one. Oh, you know what? Some of these we're not going to be able to do. A squared minus 6a plus 9 over a minus 7, and I'm multiplying that times a squared plus 3a minus 18 over a minus 3 squared. Give that a shot, Jake. I know it's nice outside, you want to be out there playing, but that means I don't want to open the window so you can hear the kids screaming and the light as they play. Anything? Where'd they go? Let's kill it. We get something to cross off? Yeah. Okay, so this is just because. What times what gives you 18 when add or subtract gives you 3? Plus 6 minus 3? You get that kind of factor out to that? Oh, it's kind of what it breaks down to. Although it doesn't look like a lot of things break down, do they?
Okay.
These two will cross off. With these two. This This a minus 7 doesn't cross off with anything, so you're left with that right there. A plus 6 times a minus 3 all over a minus 7.
I was so close, I was afraid I was.
Okay, that's, yeah, what happened?
One day I can figure it.
Oh, why did they have to do things with cubes in it? Alright, and then this, children, check this out. What about division? We just did multiplication. How is division different than multiplication? It isn't, you just have to remember to flip the second one and multiply. So here's your for example. Let's say you have this. X squared plus 3x minus 28 all over x squared plus 4x plus 4 divided by x squared minus 49 over x squared minus 5x minus 14. What do you suppose I'm going to tell you you have to do? Ryan Schwartz? Not yet. Well, you could, yes. Like with any division of fractions, you can't cross cancel until you flip these things to their opposite places. The x squared minus 5x minus 14 has to go up there, and the x squared minus 49 has to go down there, and then you can make it times. You always flip and multiply by the second fraction. And then, Lutz, you can factor them. This factors into what? Alexa, what times what gives you negative 28, add together gives you 3? You say x plus 7 times x minus 4?
Yeah, that.
Perfect. What times what gives you x squared plus 4x plus 4? Sammy? X plus 2 times x plus 2. What times what gives you negative 14, add together gives you negative 5? I'm guessing x minus 7 times x plus 2. And what times what gives you x squared minus 49? Jacob?
X minus 7, x plus 7.
X minus 7 times x plus 7. And then you look to see if anything will cross off. And it looks like what? X plus 2 crosses off with an x plus 2, a minus 7 with a minus 7, a plus 7 with a plus 7, a plus 2 with no. That's it. X minus 4 over x plus 2. Like that, man? Who's relatively excited about this?